Hello and welcome to Basic Electrical. This PowerPoint is going to be a introduction to the concepts of basic electricity and basic electrical for the HVAC tech. It's sort of important you understand electrical because it's going to be part of your everyday job. 90% of the problems you incur is going to be electrical. And you have to know that the best HVAC technicians, the one that have the best chance of success, have a complete understanding of electrical and electrical troubleshooting. That means being able to read schematics, being able to totally dig in and understand a circuit, being able to take a piece of equipment without having a schematic or a map to the circuit available and create your own. That takes practice. It doesn't come overnight. So it's my hope that this recording and this PowerPoint presentation sort of is an introduction to that. It lays the groundwork. So we have to start off with what is electricity exactly. Okay, electricity is a fundamental element of nature. It exists, okay? We can create it, we can change its form, but it starts with an atom consisting of an electron and a proton. Okay, the proton has a positive charge. The electron has a negative charge. Now, when you put a bunch of these atoms together and the electrons jump from atom to atom, the movement of electrons causes an electrical current. Okay? Then we have to have something that the current runs in. That's the conductor. So with the use of a proper conductor, the current will move in a controllable manner that becomes usable. And I'll show you an example of a circuit in a moment here. So when we talk about electricity, it's the movement of the current. Electronics is the study of the movement of electricity through wires, switches, loads, and other devices. Okay. Now, conductors, which is what I just mentioned a minute ago, is what the electrons move through, are substances like wire, metal, earth, and water where electrical current can easily pass. Okay. Keep in mind that your body is also a great conductor of electricity. The combination of the water and the salt that your body is created from is a good conductor of electricity. Insulators are the opposite of conductors. Insulators do not allow electrons to flow easily. Okay, they're substances such as rubber, cloth, dry wood, glass, and some other substances now that resist the flow of electricity. You'll see if you take a look out at the street in front of your house or in front of your building that insulators are found on the top of power poles and around wires. Insulators are there for safety and to also isolate the electrical wires. Most insulators you'll deal with is rubber or plastic. Electricity is produced by four methods. Okay, friction is what you get like when you create static electricity. Okay, you shove your feet along carpet or touch something on a cold day, you get a static electricity. Chemically is how electricity is produced in a battery. Magnetism is how electricity is produced in a power plant, and mechanical is how electricity is produced in a thermocouple. Electromagnetic force is one that is created by a magnet spinning inside wires. Okay, the current that is generated by the spinning magnet is sent out over wires to do the work. That's how most generators at power plants work. This is the current that's generated is power, voltage, and amperage. Okay, electromagnetic force. Take a magnet, spin it in some wires, and create power, voltage, and amperage. Voltage is the potential for electricity to do work. Voltage is measured in volts. Okay, your household current in the United States is 120 volts. Coming into your house most often in the United States is 240 volts. We'll talk about that more in a little bit. Current is the movement of electrons. Current is measured in amps and recorded in amps. Okay, current is how fast the electrons are moving. Resistance is the third piece of our puzzle. Resistance is the force that opposes electrical flow. Okay, if there would be no resistance, then current would run uncontrolled, and uncontrolled current is what we call as a short circuit. Resistance is measured in ohms. Wattage is the measurement of power. Okay, 1 watt equals 1 amp of current flowing with a pressure of 1 volt. Okay, watts are used by the power company to bill customers. Now, we have two types of current we're going to talk about. First of all, there's direct current. Direct current is what you see in like automotive, computers, okay? It's positive and negative. Alternating current is what we see in the household appliances, the outlets, and most of our heavy electrical loads in HVAC is alternating current. Direct current is known as DC. Okay, direct current is what's produced by batteries. It's what's used, as I said, in automotive. Direct current's used inside high-tech electrical devices. Your computer, your iPad, your cell phone, all uses direct current. Okay, a lot of the higher end and more expensive control devices in building controls use direct current as well. That's why we have to talk about it a little bit, because it's where the world is going. Alternating current is known as AC. Alternating current is what's available from your power company. It has a wave pattern to the voltage levels that vary between a positive or negative. Okay, in the United States, this change from positive to negative back to positive happens about 60 times a second. Okay, that's called hertz. So we have our wave pattern here. Okay, this is an alternating current. It's called a sine wave. Okay, quarter cycle is from 0 to your positive 120 volts. Okay, then half cycle brings it back down to 0. Our 3/4 cycle takes it to a negative 120 volts, and then our complete 360-degree cycle, because if you put this in a circle, you'll see 360 degrees, is one cycle brings it back to 0. So 60 times a second we do this complete cycle of to a positive 120, negative 120, and then back to 0. This is a 240 volt differential. If you take a look here, you have a 120 volt positive, 120 volt negative. That's 240 volts, because a positive plus a negative, okay, or sorry, you subtract these two numbers, so you have 120 minus 120 is 240. Two negatives together is a positive. But the point is that this AC sine wave, 120 volts positive, negative, the complete 360-degree cycle happens 60 times a second in the United States. That is frequency. Frequency is the measurement of the AC voltage shift from positive to negative. It's measured in hertz, Hz, okay, based on times per second or cycles per second. In the United States, this is 60 hertz. In Europe, it is 50 hertz. That's why it's extremely important to know where your piece of equipment is coming from. Always check. Line voltage is the power coming in from the power company. Line voltage is a high voltage and very often can cause you serious harm, if not death. We're talking 120 volts, 240 volts, 460. Okay, you were talking very high voltage. Line voltage is available from the wall plugs around your home or office or school. Control voltage is a lower voltage. Control voltage in the HVAC industry is about 24 VAC. Now, when you measure it, it's going to be much closer to 26, but we'll get more into that when we talk about transformers. VAC is voltage AC, or alternating current voltage. Control voltage is designed to be easier and safer to handle. Now, we need to talk about what a circuit is. I've mentioned electrical circuits a couple times. An electrical circuit is a full path for electricity. A circuit must consist of 4 parts. Has to have a source, a switch, a path, and a load. So if I jump over to one of my a simulator I have up, okay, we have a partial circuit here. Okay, I don't have the full circuit. I have my source, which is 120 volts. Okay, line 1 and 0, 120 volt differential between the two, 120 minus 0. Okay, I have my path. This is my dotted line wire coming to the bulb, but I don't have a bulb. You'll see that that's empty right now. Now I'm going to go ahead and drag a bulb in here. Okay, and so now I have my path I have my load, and I have another path. The path is the wire, basically. Okay, in this example, I don't have a switch. Okay, switch would, in this example, go right here. Okay, but I don't have a switch here. Okay, so 4 parts in a circuit: source, switch, path, and load. The load is what does work, path is the wire, source might be your plug in the wall. Okay, the source can be a battery, a transformer, a wall electrical outlet, a power line or breaker panel, or a power plant. Okay, your source is basically where you're looking at it from. It's wherever the power is coming from into what you're working for. So your source might be a wall outlet, but for an electrician who's building the building, it might be a power line, might be a breaker panel. Okay, for the power company, it's the power plant. A path is a wire, circuit board, could be a piece of grounding strap. A path has to have very low resistance. The low resistance allows electrons to move freely and without heat. The minute I increase resistance, I slow the electrons down and I actually create heat. So a path with a high resistance will heat up. A switch is a valve or a gate that stops the free flow of electrical. This is done by opening the path. Now, I want you to think about a faucet. When you have a water faucet, and if you open it, the water comes out. If you close it, the water stops. For electrical and for any electrical switching devices, it's exactly the opposite. An open switch stops the path of the flow of the electrons because it actually is an opening in the path. We're opening the wire. A closed switch is a path that's complete and allows the flow of electrons. So if I have a wire here and I do a switch, okay, and I come out to my light bulb and I come back to my other neutral, okay, that's an open switch. If you look here, we don't have a complete path. We have an opening in the path. Now, if I want to close that switch, okay, that switch is now closed there. I now have a complete path for the electrons to flow. A load is the portion of electricity that does work. Okay, it can be a light bulb, could be a motor, could be a heat strip, could be a coil. So if we go back over here to my simulator, okay, the load is that light bulb. Okay, it's something that does work. Doesn't have to be a single light bulb, could be 2 or more light bulbs. And again, if I have 2 light bulbs in here that are doing the work, we have 2 light bulbs. But the load is something that does work. Okay, heat strip, work is putting off the heat. Motor, the work is turning the shaft. A coil, the work is creating a magnetic field. Okay, pictures of circuits are called schematic diagrams. These diagrams are composed of symbols that represent each part of the circuit. These symbols are called schematic symbols. So here's an example of a schematic of a basic circuit. We have our line 1, we have our neutral, we have our switch, and we have our load. In this case, it's a light bulb. So if line 1 in neutral, okay, is 120 volts. Switch in this case is open. Bulb is not energized because I have this break in the circuit right over here at the switch 1. Okay, schematics of a switch. Every device has a schematic symbol that goes along with it. Okay, you have a single pole switch, single throw, single pole, double throw. It's either on one or the other wires. Here it can be open, so something's truly off. The double throw means that it could be 2 different devices. Okay, could be like a conveyor belt, forward, backwards, fan, high, low. The 2 cannot be energized at the same time. So we have poles and throws. Single pole, double throw. Neither one of these will be energized at the same time. Source on a schematic can be labeled L1, L2, N, or anything else. It's usually on at one side of the schematic or top or bottom, and everything else works from there. Careful, schematic diagrams can have more than one source. Loads are shown by either an actual schematic symbol for the load or by a circle with a letter and key. Loads are the portion of the circuit that does the work. Okay, this is an example of a more complex schematic. Okay, again, up here we have L1 and neutral. Okay, that's my source. Okay, we know that the source is 120 because we're saying it right at the key of the schematic. Okay, every one of these here is a symbol. You'll notice they're all labeled with something. Okay, because symbols that have the same label mean that they're connected. So C2, C2, and C2 all works together because it's one device. C1 and C1 down here is a different device. Okay, PS1 and PS2, two different devices. So we'll talk more about these symbols as we move forward. Now, whenever you work around electricity, be it in your school shop, be it at home, be it on a circuit board you're building yourself, make sure everything you're working from is unplugged and turned off when you're starting your work. Okay, use black wires for line voltage source, use white wire for line voltage neutral, use red wire for control voltage source, and use orange wire for control voltage common. Okay, now the reason we talk about these wire colors is as you're starting off, it just makes it easier for you to follow. And if you get used to following with a certain wire pattern, you'll rarely confuse and have issues with sparks, smoke, and other bad stuff flying out of your circuits.